Hello everyone. Today we are going to discuss the design of a parking lot, and this is one of the most common questions that is asked in a low level design interview. It is asked whether you are appearing for SD1, SD2 or even senior software engineer interview. So what we are going to do is we will go through the problem statement, then we'll break the problem in multiple classes. And after that, we will discuss what design pattern would be suitable for this use case, solving this use case. And after that, we are going to write our code in Java. And finally, we are going to test our Java code in the CodeZym editor. I'm not going to write any main method or add any test cases of my own. CodeZym's testing engine will take care of all of these things. So let's go through the problem statement. This is question number 7 on CodeZym. We have got a parking lot which is having multiple floors, and we can park either two-wheeler vehicles or four-wheeler vehicles. And on each floor, vehicles are parked in parking spots. Those parking spots are arranged in rows and columns on each floor. And for simplicity, we will assume that each floor will have the same number of rows and each row will have the same number of columns. Next, let's discuss the methods that we need to implement. The first one is init. This is sort of our constructor or initializer. It takes two parameters. The first one is a helper object and second one is a parking array. Helper is used mostly for logging and debugging. For example, you should use helper.print and helper.println for printing logs. If you use system.out.println, then your logs will not be visible. Parking array gives the blueprint of all the parking spots that are there on the parking lot. For example, this parking array is actually depicting a parking floor which has got one floor and four rows on each floor and four columns in each row. So on floor 0, that is on the first floor, we have got total 6 four-wheeler parking spots and 7 two-wheeler parking spots and 3 inactive spots. Now you cannot park your vehicle in an inactive spot. The second method, which you might have guessed, is the park method, which basically parks a vehicle. So it takes a vehicle type, which can be either 2 or 4, depending on whether it is a two-wheeler vehicle or a four-wheeler vehicle. Then it also takes a parking strategy, which actually decides which algorithm will be used for assigning the parking spot. It also takes the vehicle's vehicle number and ticket ID. It finds a free spot and then it returns its spot ID. Let's, for example, we found a parking spot on floor 2, row 0 and column 15. So its spot ID will be 202-0-15. Now parking strategy has two values. That is, as of now, we need to implement two different algorithms for the park method. Let's see them. When park strategy is 0, then we have to return the parking spot or the free parking spot at the lowest index for that vehicle type. For example, let's consider the array in the previous example, and this array was called, that is, this parking lot was called with the park method for vehicle type 4 and parking strategy 0, which we are discussing, and a vehicle number and ticket ID. For vehicle type 4, this is the first spot, so it should return 0, 0, 0, that is 0th floor, 0th row and 0th column. Now let's suppose again the park method is called for vehicle type 4, then it will return 0, 0 and 1 because this is the 1th column or first column. Next, what if the park method was called with vehicle type 2? So this is the first free one. So we have returned here 0-0-2, that is floor 0, row 0 and column 2. So parking strategy 0 is there. Next, let's see the parking strategy 1. If the parking strategy is 1, then you have to follow two rules. The first one is you have to find the floor with maximum number of free spots for that given vehicle type. And the second is if there are multiple floors which are having maximum number of free spots, then we will choose the floor which is at the lowest index. Let's see an example. We have a parking array which has got 4 floors, floor 0, 1 and 2 and 3. And the park method which called with a vehicle type 4. So how we will calculate? Floor 0 has got two four-wheeler parking spots. Floor 1 has got three four-wheeler parking spots. Floor 2 has got only one parking spot and floor 3 has again got three four-wheeler parking spots. So floor 0 and floor 2 are rejected because they have already less number of parking spots. Floor 1 and floor 3 both have got three four-wheeler parking spots. Now we will choose floor 1 because it comes before floor 3. And finally, we will choose the first available four-wheeler parking spot. So the final answer will be floor 1, row 0 and column 3. So this is how parking strategy 1 should assign the parking spot. Apart from the park method, there are a few more methods that we need to implement. We have got the remove vehicle. You are given a spot ID and you have to remove the parked vehicle from the spot ID. If you remember, the spot ID was assigned in the park method. Then you have got the search vehicle where you will be given a query. Your query can be either vehicle number or it can be the ticket ID that was passed along in the park method, and you have to return the spot ID for that vehicle. And finally, you have got the free spots count. So you will be given a floor and a vehicle type, and you have to return the number of free spots for that vehicle type on that floor. This is mostly used for the display board, which we see on different floors in the lift. Now let's see a few method calls which will make the whole thing even more clear. This is the parking array that we have been seeing for our example. Let's suppose it is called for a park is called for a two-wheeler vehicle and a vehicle number and a ticket ID, and parking strategy 0. That is, we need to find the nearest free parking spot for a two-wheeler vehicle type. So this is the free spot. So we return 002, 0th floor, 0th row and second column. Now next search is called with the vehicle number or the ticket ID. So we return the spot ID which was assigned in the park method. And at this point, if we call the get free spots count method for a two-wheeler vehicle on floor 0, then it will return 6 because total 7 free spots were there. One is already occupied. So it should return 6 now. Next, what we do is we do a remove vehicle from that spot. So it should return true, and because a vehicle is parked right now at 002. And next, we at this point, if we call the get free spots count for a two-wheeler vehicle type on floor 0, then now this spot is free. So it should return 7, 2, 2, 4, 3, 7. So hopefully things are clear now. Now let's go ahead and discuss the solution. Before we start solving this problem, we have to copy this default code which contains this class solution, and we will save it in our local laptop or desktop as solution.java file. Now we can open that Java file, solution.java, using any editor that we are using. It can be IntelliJ or Visual Studio Code or Eclipse or anything that you are using. After that, I will also recommend you to see this getting started with CodeZym YouTube video. This is a 3-4 minute video and it will clarify things for you in case you are starting out on CodeZym. Finally, here are all the methods that we need to implement in class solution. We have got the init, we have got the park, we have got the remove vehicle, we have the search vehicle and get free spots count. Now looking at these methods also gives you a clue about what are all the classes that we will need to implement this problem. We already know that parking spot has got multiple floors, and we have the park, the remove vehicle and get free spots count on each floor. So we have a separate class parking floor which will take care of these things. Again, we also need the search functionality, search vehicle, and generally it's good to differentiate or put the search functionality in a separate class or manager of its own. That's what I have done. I have put the search functionality in the search manager class. We'll go through all these classes one by one as we move ahead. Finally, we also have a parking strategy which actually tells what are the different algorithms that will be used for assigning a parking spot. As of now, there are 2 parking strategy values. Later, there can be a 3rd parking strategy or a 4th parking strategy. So I have a separate class called Park Manager. This will make it easier to add more and more parking strategies in future without actually uh, editing code inside the parking floor class or search manager class. So let's see them one by one. Here are all the classes at once. We have the parking floor, which takes care of park vehicle, unparked vehicle or remove vehicle, and get free spots count for each floor. Then we have the search manager, which will index and search all the parking details. Then we have the parking strategy interface. We'll be using strategy pattern here. Why? Because we have got two algorithms and they both can use the same parameter and return the same thing, which is the spot ID. So we have the parking floors and the vehicle type, and the class park manager is sort of our factory or the place which or the class which will control both these nearest parking strategy, that is parking strategy 0, and most free spots parking strategy, that is parking strategy 1. So let's move ahead and see all the code one by one. Our class parking floor is responsible for parking the vehicle, removing the vehicle, and getting the number of free spots count for a given vehicle type for that floor. Parking array has all the rows and columns for parking the vehicles. Reserved is true or false for each row and column. It tells whether that particular parking spot at that given row and column is reserved or not. And finally, we have got the free spots count, which is actually the number of free spots for each vehicle type, so that the return type or the answer for this method get free spots count can be returned in order of 1. We will see the actual code of all these methods one by one. For now, these are the responsibilities of the parking floor class. Next is the search manager class, which has got the responsibility to index the parking details and search them whenever required. So it keeps a hash map or a cache to store all the data. Uh, for indexing, it takes the spot ID, vehicle number and ticket ID of the vehicle, and it puts the spot ID against both vehicle number and ticket ID. For searching, it simply fetches the corresponding spot ID for that query. The query can be either vehicle number or ticket ID. So it is a pretty simple class for now. Now let's go through the actual code in the different methods of class solution one by one. This will be a top-down approach, which will make us understand the whole solution much better. So what the init method does is it initializes all the parking floor objects in the parking floors array, and each parking floor takes a floor number, the corresponding parking array, which has got all the rows and columns for that floor, and all the vehicle types. Basically, they are just 2, 2 and 4. Init method initializes all the parking floor objects in the array in the solution class. Whenever a parking floor object is initialized, it first of all initializes the count for each vehicle type. Then what it does is it goes through all the rows and columns in the parking array for that floor, and then it counts the number of free spots for each vehicle type. This will be useful in the park and remove vehicle method that we'll see next. After init, the next method in class solution is park. It calls the park manager.park, which does the actual parking and also returns a valid spot ID. If the spot ID is valid, that is it is not empty, then the parking details are indexed. The parking details are your spot ID, vehicle number and ticket ID, which can be searched later. The park method inside class park manager uses a bunch of algorithms for doing the actual parking. For parking strategy 0, it uses nearest parking strategy, and for parking strategy 1, it uses most free spots parking strategy. Now, if tomorrow we have to add a third sort of parking strategy, that is parking strategy equal to 2, then we will make the algorithm class implement this parking strategy interface and simply add its object to this algorithms array. So this makes it very easy to add new algorithms for assigning the parking spot without actually changing code in other classes, uh, like class parking floor or class search manager. That's the benefit of using a strategy pattern here. Class nearest parking strategy implements the parking strategy equal to 0. So its park method simply goes through all the floors and it tries to park your vehicle on each floor. And if it gets a valid spot ID, then it simply returns it. It means a valid spot ID has been found. The algorithm for parking strategy equal to 1 is implemented by this class most free spots parking strategy. It does two things. First of all, it tries to find the floor which has got the maximum number of free spots count for that given vehicle type, that is two-wheeler or four-wheeler. If it is able to find one such floor, then it tries to park there and returns the corresponding spot ID. Now both the algorithm classes that we saw actually call the park method inside the class parking floor to do the actual parking. So what this park method does is it goes through all the rows and columns and tries to find an unreserved parking spot for that given vehicle type. And if it is able to find one, then it reserves that spot and increases the or decreases the free spots count for that vehicle type by 1 and returns the spot ID, which is floor hyphen row hyphen column. If it is not able to find the corresponding spots, then it returns an empty string. So to summarize our overall parking functionality or park functionality to park the vehicle in a given parking spot, the method park inside class solution calls the park method from the class park manager. The class park manager has the object or instances of different algorithms. Its park method calls one of those algorithms based on the parking strategy value. Now, both these algorithms at some point call the park method inside the class parking floor, which does the actual parking. So this is how whole assigning a spot to a given vehicle based on its vehicle type works, and also depending on the parking strategy. After the park method, the next method in class solution is remove vehicle, which takes in a spot ID. So what this method does is it extracts the floor index from this spot ID. So for example, in this spot ID, the floor is 2. So that is extracted. And for that given floor index, we have the corresponding entry in floors array, and remove vehicle is called for that floor object. Inside the class parking floor, the remove vehicle method, which is called from this remove vehicle method inside class solution, it using the row and column from where we have to unpark the vehicle or remove the vehicle. First of all, it's reserved for that row and column is marked as false if a vehicle is parked there, and we also increment the number of free spots count for that given vehicle type in that floor, and finally we return true. If there is no vehicle parked in that row or column, or the vehicle type is invalid, then we return false. After remove, the next method is search vehicle. This functionality is taken care of by the search method inside search manager class. The query can be your vehicle number or your ticket ID. The search manager inside the or the search method inside the search manager class actually tries to find the corresponding spot ID for that query in our case, which is actually a hash map. If it is able to find, fine, else it returns an empty string. The last method inside class solution is get free spots count for a given floor and a given vehicle type. So we get the corresponding floor object and call the get free spots count method there. Now this free spots count on each floor is actually maintained in this hash map of vehicle type versus number of free spots for that given vehicle type. So we simply fetch the count from the hash map and return it. Now that our solution is complete, let's select all and copy paste it into the CodeZym editor for testing. And do not forget to comment the code at the bottom. I will show you how. So let's select all and copy to the editor and paste it here. Also, I was talking about this code. This is the helper code that we uncommented when we copied it to our local editor. So let's comment it back, else it will give compiler error, duplicate interface definition and helper class definition, and let's run it. It should not take much, and all the code it will compile, and all now we see that all sample test cases have passed. So let's submit it and see that it passes all the test cases. It has compiled and now it will run all the test cases one by one. As the number of test cases complete, then this number of tests will keep changing. 10, 11 are passed out of 13 test cases. Now all the test cases have passed. This means our code was indeed correct. Seeing your code run and pass all the test cases gives you the confidence that if you get this or a similar question in an interview, then you will be able to do well there also. I will put all this code in a blog and add the link to that blog in the description section and also in the pinned comments. So good luck seeing it. And I wish you the best of luck for your interview preparation. I hope that you get the job and the salary that you are looking for. You can reach out to me on LinkedIn. I will put my LinkedIn account link on in the description section and in the pinned comments as well. And also keep trying other questions from CodeZym and keep improving. Best of luck. Thanks for watching.